Then let me just start, and then just interrupt me. Just interrupt me. This is not meant to be 60 minutes talk where I only talk. So when I handed this in, yeah, it sounds too much. No, when it says here GUI elements, in the end, it will be just a button. And when we talk about database structures, it's just a table. So, but anyway, so what I want to talk about is about codification, meaning getting Snap code transformed into Python code. So, and what you can see is the agenda. So I will just quickly tell you what drives me, and then talk about codification in Snap. What is there and how do I use it? And then also show you a little bit how that works, and yeah, see and discuss what I learned, and then have a discussion at the end. So that's my idea for the next 50 minutes. Please just interrupt me if there is anything you want to say or add or comment or complain or whatever. Yeah, I cannot read always the chat, but there is, I don't have any links for any background reading as of now, but I guess since this is recorded, you all get the video, and of course you can get my, you can get these 20 slides, no? I got something like 20 slides. Okay, so let's start. So about myself, I studied computer science a long time ago. I worked like Jens. You probably all know Jens, who is the main developer of Snap at SAP. I started teaching Scratch 5 years ago, and that was more about daughter-driven interest because my daughter was in that age. And then the last 5-6 years, I moved from some easy stuff like Scratch to App Inventor, Snap, Java, and since 2 years, I'm also teaching Python to kids. Currently, I'm running an online Python training which will start in 1 week with 130 participants. I'm working with Snap now for something like 3 years, and I really like Snap, because it's something which you really can use, not like Scratch, which is more like a toy. Okay. Okay, that's just for me. Where I'm coming from and what's driving me is that moving from a blocks language like Snap to a typing language is painful. If you go to a typing language where you have to type like Python or Java, then you have syntax, you have new environment, you have frustrations, and all the things which you don't have in Snap. That starts to stop kids. And I've seen lots of kids which were really enthusiastic and which were working on Snap for hours and days and weeks, then they got frustrated. And what I've seen is that at the age, and it's the age thing, when kids are 14 to 60, they're somehow too old for Scratch, or they don't like Snap anymore. On the other side, they're too young to understand the benefits of really learning a programming languages. And also they're not that motivated to learn the hard way. And what I've seen is that Snap, and I will talk about that, lacks a bit the options to build something real. That is what I always liked about the App Inventor, what you can see on the top, which you can probably all know this tool to build some apps. That is something where you can build something which you can use in real life. On the other hand, it's a bit like a toy because you cannot really, there's not object-oriented in it. There is not really object orientation in it. There is not a lot of computer science in it, so you cannot do a lot with it. But you can use it in real life. And that is what I think is lacking Snap. And that is one of the things which is driving me in teaching Snap and using codification to move from blocks to text and from Snap to Python. So now I want to talk, or first questions, I want to talk now about codification in Snap. What is this and how can you use this? But any questions before? Just take a look in the chat. Okay. Okay. So what is codification? There is codification. You can see this here on the top on the right, where you can click on for codification support. And that means that in Snap, something opens, and then you can use codification, but it's not used very often. It's also old, been a long time. And codification means that you can write a program in Snap, and then you can transfer the code and convert the code into the code of some other languages. There is not only Python, there also is C and some other languages. So what you can see on the bottom, on the left, you can see here there's a Snap code, ask and wait. Then you get a number, and if the number is higher than 2, then you print out, say number is big, otherwise number is small. So, and this is what you can use, what you can transfer, like here in this element code, into some code which then runs in Python or other languages. That is already there. That's standard Snap, so to speak. And you can then run this code like here in answer equals input, please enter number. That's what you can run in Python. So yeah, that is something I want to show you how this works. So you can see here, here's a variable code. Then you have some elements which are part of that. And then you can here see how the code is generated. So let me quickly show you this. And please ask questions if there is any. So let me find the right. So let's take that out. So these are standard Snap blocks. So I put them in here. No, you can see that. And then let me make this a little bit bigger. So, and then I click on it, and then in the variable code, what you can see here, then you have what the codification generated out of it. And this is, let me show you, you have here some blocks where you can map certain elements. And the main one is mapped to Python. And in codification, you not have only mapped to Python, you have lots of them. Not lots of them, some of them for other languages. And here you can see how certain blocks are mapped to code or other, how do you say, other language elements, which then can be transferred further. So if I go back now to this presentation, you can see here how this mapping creates a piece of text for each Snap command. And then for all the variables, so with the number 1, number 2, it goes on to the next mapping and then generates some code. So this is how the text is generated out of the Snap blocks, as you can see on the left. That also works for functions. So you can define a function, and then you have to create your mapping manually. So you have the header for the functions. So define my function parameter and the body, and then this body goes then where my function goes, and then so you can create this code out of these snap codes on the left. Okay, any questions? Is this in principle understandable how it works and what you can do with it? Okay, then I just continue. So this is the, I call legacy codification, which is there out of the box. But once I started out, I realized that languages in block, they not only feel differently, so they also behave differently, and they cannot be mapped one-to-one. And the codification was there for several languages, so there was not a focus on certain languages. And the languages are very different in the concepts, the vocabulary in Python and Snap. So what you can see here is, for example, you have in Python, you have a range, which in the end is just creating a list, and you could have 3 parameters. You could have a starting number, you could have an end number, and you also could have, as a third parameter, you could have a step, how far you go. So this would go -5, then -1, 2, and then 5, this for example. No? So that is something what you use to go through lists by index, no? Because you create a range which starts from 0 and then goes to the length of the list, and then you could go via the index through a list. So that's just one example which just isn't there. No? There are other things like lots of other things like strings and lists. They're treated similar. They're totally different in Snap. Lists and strings, they start with the index 0 in Python, not in as one. So there are lots of things are different, and this makes it difficult to build something which is more than just 3 blocks, and create something useful. So this is where I then started to build my own blocks, and that is what I want to show you now, where I started blocks which look and behave like Python. So for example, you have in Python, you have an input, that's a function, and this gives back what has been entered. So that is one of the blocks I created by myself. So there is not this ask anymore, now it's input. So if I have now input string, this is just a variable. And then you have here, for example, a custom block int, which creates an integer out of the input. Because also in Snap, you don't care so much about is it an integer or a text. That also Python and Snap behave differently. So then you have a number, and then you could here, you have a print. And the point is now, or also here you can see a list, print, this is a list. In Python, you have brackets at the end and the beginning. So this is now what you can see here is a piece of Snap code, which can be transferred and translated to Python code on one-to-one. So all these blocks are what I call fake Python code blocks. They're not real Snap blocks. You also can see here in the assignment. So what comes out of the input is assigned to input string. Also, this assignment is also a fake Python block. But what you can see is that the blocks and the Python code now looks very, very similar. It does not only behave the Snap code as the Python code behaves, it also looks different. And you also can see some of the syntactical things that you have a colon behind an if and an elif or the else. So that is what you have in Python. Or you can see also here the brackets of a list. So what I've done is what you can see on top, print input, assignment these blocks in Python to create blocks and code in Python to write programs which works in Snap and in Python and works as much as possible exactly the same way. Okay. Any questions so far? Just interrupt me.
There's a question in the chat. They're asking if the brackets in the list block are just syntactic sugar. Are they just in the image so that they read like Python lists?
Yeah, they are not needed because, I mean, they're not needed because the block would be taken as they are just to give, syntactic sugar, I think is the right word. It's not really needed. It just gives the impression the same as the columns. No, they're not needed. No, just gives the look and feel of Python.
Right. There's one more question in the chat. Someone asked, how did you create these codification blocks? Are they the part of a library?
No, they're only part of my private project. But I will come to that. Okay, so this is when I started, I will show you in a second. I will show you in a second how it looks. So this is once I started, I realized more and more that does not feel the same. It looks different. And you can see here, for example, the assignment, where there's a value, and where I really needed a lot of understanding on how to create some of these blocks. But you can see that or if you know Python, that they translate one-to-one to the Python code. Okay, so now I want to show you first of all here. This was the old the standard codification, and now I take a different code, and all this code here, or most of this, is I can show you this because that is has been created by myself, and some of them are very easy. The input block, for example, is just taking sorry for the German, is just taking covering the ask block. No, other ones, the assignment. Maybe I can also show you the assignment. No, not that one. Take it from here. The assignment is more complicated. No? The assignment is more complicated, but overall it is there. So if I now put this one in here and take this one out, then you can see here on the on the right, in this variable code, the code, and that is what I want to show you. I export this. So, and now I get here Python code, and now this is what, so Python, yeah, get a new one. So, and this is exactly what you've seen on the slides before. So now that is, if it doesn't fail me, enter a number, I enter 2, numbers equals 2, this is, and then some other thing, this is a list. No? So what I wanted to show you in demo is that that this code here, and I will also show you how it looks like. Here, please enter a number. I enter a number, and then it says numbers equal, and then also this is a list is printed 2 times. Maybe a little bit quick, a bit faster. So I enter a number. Number is big. So this code works in Snap, can be transformed to Python. So and that is more or less the main thing. where is it? Here. Looks also exactly the same. It looks and feels the same. So also the colors, so the colors match. So green has something to do with operations, the control, also the variables assignment. In orange, printing, sensing is blue input. So it also looks the same. So that is, yeah, this is where what I started, where I started, and then what I want to show you now is a prompt, an event loop, and some graphical user elements. So on how to build some bigger programs, not just these 5-liners, which were more for a demo, and show you how this works or could work in Snap and in Snap to transform Snap code and Snap blocks to Python programs. Any questions so far?
There's 2 more questions in the chat. So someone asked, can you use Python libraries or Snap libraries in codification, for instance, the random library?
I don't see these questions.
So it's in the chat if you scroll all the way down.
Yeah, if you use libraries Python, you random. Yeah, yeah, that is a good one. That is something you have to enter. Let me show you. Map to Python. I guess I guess I can find it now quickly. I hope so. Where is this? No, map to Python. The edit. Where is this? You can see a higher order function that all works also, that is fine. But this is unfortunately very big, and therefore random, I'm not sure. Here you can see this. There was a question for random. So here is a map randint, and this is mapped to the header import random. And randint here is mapped to code random, randint, and then you have these to number 1 and number 2, which fills into randint. So there is, you can use randint and import it from the random library. But that is one of the tricky things, or more tricky, a bit more tricky, because you have to include this import. But it works. I mean, it's also then the this randint. If I use this randint, maybe this would be a nice demo. Then it would import. It would create these 2 lines in the Python code, and it would work.
Right. There's another question. Someone asked, could you share the blocks for codification?
Yeah. I can do that. Yeah. Okay. So but what I want to do now is go back. It took a lot of time to build blocks and understand how Python works and how Python is different to Snap. But the benefit is, since setting this codification up, you also learn a lot. So this was worth it. So, but then I wanted to understand more and see if you can build useful programs, something you can, yeah, some bigger stuff. So, and this is why I want to show you now the prompt, the event loop, and some graphical user elements, and how to enhance this to, yeah, more topics so you can build more. So yeah, so what you can see here is a Python program. I will show in a second. So what you can see here is you have a prompt in Python. And then you have just an event loop and you just add some numbers, 1, 3, 6, 7, and then you can see the contents of a table. So very, very simple, the contents of a table. So you see a Tim, Jack, and Bill. And then you can add something to this table, a different number, and enhance it. So it is very simple, but in the end, what you have behind it is a table. And of course, you could also link these tables and then blow this up into SQL and databases and so on. But here it's just a very, very small table with 3 entries. And this is what you can see on the left. This is the prompt I created I built in Snap. And what you can see here already is that this works exactly the same as in Python. So application is a word which is a little bit too big for this, no? But what you can see is that you can build something. You have a prompt, which you have always, or we have in standard Python, and you can build something which you can transform one-to-one to Python, and it works. I just want to show this very, very quickly because I think this is oh, I'm not sure if this is now. No, sorry. No, let's not do it like this. Let's take this one. So you can see just to the one shows you all the data. To view the menu again, then you have a 6. Then you can see the menu again. I enter another 6. So and then 3, I add a new entry. Very, very quick. So and now I can see if I look into my data again, that's what I just created. No? So that's a Python program. No? That's a Python program. And that is what is coming out of a Snap program. What I want to show you now, if that's, here, this is an error I couldn't fix so quickly. It just gives out the elements of every line in the table separate. No? But in principle, you should see that this prompt, which I created in Snap, works exactly as in Python. To view the menu again, that was a 6. Oh yeah, and then of course also here the 3, where can I add something. So, and then you can see what I just add. So this is not about showing off what I built in Snap. It is just to show that you can build something in Snap and transform it one-to-one into a Python program. So this was now something, and you can of course imagine this is now small because it's for demo, but you can easily imagine that you can build tables much, much bigger, and you can link tables and reference tables and all that stuff. Okay, so this now shows you, and it gives you also, that is important, so it gives you also a feeling for the architecture. You have a event loop, and more or less endless loop. And you can see here that the Snap program on the left is exactly the same in Python on the right. And you can see also how these things are linked. You can see how this is linked. So that is one. And now what I want to show you is, and I'm happy that I have enough time that we can have discussions and questions for graphical user elements. So this is now something, next step. So you can see here, there is a button, which I will show you in Snap. And then you can see here on the right, there is a button in a tkinter program. So tkinter is something which is used to build a graphical user interface, what you can see here, onto a Python program. So this was, now let me show you this, the button. And yeah, you can see here this button. Let me make this a bit bigger. You can see a button. So the button, if I go with a mouse on the button, it changes its size. So, and if I click on the button, it also changes, yeah, its appearance. And that is what I cannot show you now. That is what I was working on, is then to map the code, what you have in tkinter. And you can see here, this is exactly the same code as you have in tkinter, to create the Python code and then map this. But that is something, yeah, it's just mapping text. It is not something very complicated, no? So I'm sorry that it's so messy here. That's all not relevant. So what I want to show you is that here I have a button which has a certain behavior in Snap, and how this potentially could be transformed into tkinter. I started, and that is what you can see here, is to have something like a small GUI library, to have not only this button, but also have a checkbox, a radio button, a label, an entry, and a list box. This, I think, should be sufficient. And I tried, or I started to build this like similar class hierarchy you have with the widgets in Python. So, and the idea, of course, is that you can create some buttons, and you create the Snap code, and then you create a program out of the Snap code, which then works more or less similar to the Snap program in Python as the Snap program. That's not that easy because you have the concepts are very different. No? But I still think it gives you an idea on Snap. It gives you an idea in programming in Snap without being too complicated on what does it really mean to have a graphical user interface. Because in Snap you only have where is it? Sorry, you have sprites which have costumes, and it's not that difficult to understand and to program in Snap. Yeah, buttons, that's what you've seen, or checkboxes, to program these widgets in Snap so they behave in Snap as you would expect from a graphical user interface. So this shows you the Snap blocks, which would be needed to translate into these Python code. And it should feel, work and feel in Snap, of course, similar to Python. So it should be also class hierarchy of widgets and so on. No? It should, so you could build in Snap programs which have, yeah, some buttons in the list box, and you should be able to transfer this to Python. So you can build very simple application in Snap, which could be transformed to Python via codification and run immediately. So also, so you wouldn't have not only here this prompt, but you could have a list box with not the 3 numbers which you use to manage this table, but to have 3 buttons, and then you click on the buttons, and then you see the list, or delete an entry, or add an entry, these kind of things. So, okay, any questions so far? More questions? Okay. So I wanted to show you how you can build a prompt, yeah, with an event loop in Snap, how we graph the user interface in Snap. Oh, maybe there's a question. About your use case, yes, the use case, yes. So first of all, just one slide, and then we can discuss. Just one slide, what I've seen and learned. Also after, yeah, that Snap is much more lively, visual, and more intuitive than Python. It goes with Snap, you don't have to think. And in Python, that is also when teaching, you really have to explain everything. Also seen that you can learn a lot in Snap. There is an article by Brian, Why Do I Have to Learn This Baby Language? Where he clearly says, no, you can all do functional programming. You can learn object-oriented programming in Snap. There's a lot of things what you can learn. Yeah, what Snap lacks a bit, this is that you cannot build so many useful applications. And what I also seen that you can learn a lot by implementing fake Python blocks. And I learned a lot of Python by just creating these blocks. Also, what I've seen is that when I moved from Snap to Python, or moved, so to speak, I lost, yeah, the feeling of the colors, for example. That's something else which is there in Snap and makes it very, very easy to understand what I'm doing, how does the program work, without really thinking. In Python, everything has to be explicit, and you really have to, in these typing languages, yeah, know really exactly what you're doing. There is not a lot of room for intuition. So the question in the chat was, what is the use case? The use case for this? Is it, so what I've done is I used what you can see here on the left. I gave an introduction into some Python, a fake Python block, fake Snap blocks, and showed them how you can create Python code of it. And I've used this in a, yeah, right until now, small amount to give kids an idea on how to move, how does a text language work? If you only know Scratch and Snap, you need to learn, okay, how does it work? What does it mean? What is a keyword? No? There's so many things you don't need to learn and need to understand. But the question here was for the use case, you can use these fake Python blocks to ease the move from Snap to a programming language. And what I've seen is that it has created for me a lot of work to create all these blocks. It is picked up by kids very quickly, so they quickly understand that that the syntax, which you can see on the Snap blocks, really has to be there one-on-one, and they grasp some ideas of the Python language. Yeah, that's what I hope, a bit faster than if you start from Python directly. So this is, yeah, somebody will AC wants to say something. Yeah, just go ahead.
So thank you for that, because that was, when I was watching through this, that was the use case that I really felt like this was well designed for, is to have like the pivot point for people who have some reasonable fluence in even complicated Snap. As people who own no other programming languages, we read the implied structure in the Snap blocks. But when you move to syntax dependent languages, those little bits throw kids so much to the point where they just kind of fall off the face. But this, I could see this being really great as a way of just helping establish the transition point. It's not that they're going to write complicated Python programs through this interface, because as you found out, it is so much more work to build the translation blocks than to just write the program in Python. But I'd love to try it out and see if you find it makes that pivot point easier for kids.
Yeah. Oh, I don't know how to do this now because there are more questions in the chat. Is there a fork? No, it's not a fork. Everything you've seen is standard. I mean, I can show you this here. Everything is standard snap. It is just that the blocks on the left here, this for example, no, this block example, that's my own one. That is created, no, and it is still in a bit, let's say, experimental phase. No, what would be good is to have here this input, for example. What would be good is to have, yeah, something like 50, 60 blocks. So you have some kind of standard blocks where you can see, where you can know this works and this is reliable. No? But here, Randy McDonald, it's not a fork of default snap, it's poorly snap. Okay, any more questions? I mean, we still got 10, 30 minutes and
can I follow up my question?
Yeah, okay, sorry, I didn't want to mean to interrupt you.
Yeah, no worries. I'm curious as to how you created these. Are these custom blocks, or is there
a
toolkit?
Blocks. These are custom blocks. No toolkit. Everything is standard snap. So you can see here's the input block. So it's just here. That is just a question. Sorry for this is just a custom block. So that's just a custom block, and it uses in a very simple way the block you already know, no? And this block you already know here in Snap. This does not give you anything back, but in Python, input is what you would call a function in Snap.
And I'll just ask one more. So you showed that you got text output. You got almost a translation to Python.
Yeah.
Can you show an example of how that works with your blocks?
That is, where is this? This is oh, sorry, let's go here. Maybe see it.
I mean, I'm assuming that's what happens, right? You can actually
So
click on a block and
that.
get the text.
So here you can see that. Yeah. So here you can see that. What you do is you create your code in Snap, put this to the script, and then the code is set to the script and it's used mapped to Python. So if I click on this, if I can go to the code, and then I see here the code, which is out of this initialized menu global event loop. No, so this is what has been created, and that's what I could export now. This is what has been created out of the code, what is behind here.
Okay, and then you can just export that text.
Correct, and then this export text is just exported. Yeah.
This would be great. And then are you willing to share some of this so that we can play around with it?
Sure. Yeah, I can share that. Yeah.
Thank you.
So it is just, I mean, if you go to this map to Python block, and that is the main one, this is where all this mapping is happening. And that is why it is so big and takes so much time to open. There is, the mapping. So that is one part. But there has been, for me, a lot of trial and error. For example, here you have an and which combines, and that is then easy to translate, but that is Yeah, and let me show you some other ones which are more. There's some of them here. This is the range what you have in Python. No, when you just want to go 2, 4, and you go, that's 1, boom, here 2, 3, 4. That works exactly like in Python. And this is this feeding things which is difficult for me to describe. I mean, if you get used to these kind of blocks, then Python becomes very easy because this block for the range here behaves exactly like in Python. But you can see there has been some effort behind it to really to do this, because, for example, you also have to cater for what do you do if you create this well, for example, for, no, then you get an error. No, sorry that it's in German. And also for some of what I want to show you is for element in list. I think, is it this one? Yeah, here, that also you can see there are lots of thoughts in some of them. Some of these, what you have in Python for element and list, do something. Now that's how to loop. So that is also something. But what I want to show you here is also here this map lambda. So you can also do higher order function. You can do a lot of complicated things. And that is why, I mean, what I showed you was just the table here, what you can still see here on the right side, here, this table. But I'm pretty sure you can build really 2, 3 tables, reference them, and do some kind of SQL on a snap level, and then transfer this to Python. Because also these higher order functions and list comprehensions and so on, what you have in Python, you can do and build yourself, build it yourself. Okay, so there are more questions. This is wonderful. So Philip Wang, can this be added to extensions? This is something you have to add, ask Jens and the ones who make decisions. As far as so far, this is just a project which is also yeah, inside.
Okay, thank you.
Can this be added? Yes. It looks like you 2 of text code and header, and we're adding everything to those strings. That's correct. So there are some of the blocks. So some of the blocks, they just map 1 to 1, and some of them also need a header. This depends. If you have functions, for example, need a header, or this random, the libraries, then of course for end. Then of course you also need to import, and then you also need a header. Okay, script and header.
If you put something in the header, is it there only once, or do you get duplicates?
Yeah, that is the problem. Of course you get duplicates. You get duplicates, and this is one of the things which is not nice, because then if you use went int 5 times, then you see the Python code, which of course it works, the Python code works, but it becomes ugly and unreadable, and you have to delete it. Yeah. Okay, I see the pro to explain Python for loop already in Snap. Other fake Python blocks loop that are complex, better to on the stage instead of, yeah, this is exactly what I would like to discuss. Who is this? Claudia and Gisbert Love. If you, what I showed you is a lot of stuff I built, and that of course is complicated. If everything is there, what you can see on the left, and you build something, and then you create the Python code directly out of it, and then that is something additionally, also more graphical user interfaces, or the architecture of a prompt, then I think there is some benefit. So, but that is something where Claudia and Gisbert, you can contradict me.
Okay, do you have an email or so, something like that, to contact you?
Yeah.
Okay.
I have an email, yes.
I'll do so, thank you.
That is, but I mean, very honestly, that is something I was thinking. I've been thinking the last 2 years. Is it really worth it? No, that's why you can see it. Is it really worth it? And there are two things to this. I mean, creating all of this is a lot of effort. But once it's there, and this is where I'm lacking experience in teaching this and trying this out. Once it's there, it's easy. To build this is something you can learn in 5 minutes. How to build this. I mean, you don't even need to really understand a lot of Snap. To build this here on the left takes a kid to understand this 1 hour. Of course, it doesn't make sense then to move to Python. I mean, the whole thing is only there if you're really good in Snap and you understand it. Then you can teach and then you can move to Python. And I'm not sure when the perfect time is for this. No, there was another question. When would we do this? No, I don't know when the perfect time is for this. That is where also I'm lacking experience. Okay, we still got 4 minutes.
Well, I was thinking about that transition point myself, and the tkinter example was so interesting because in so many ways, GUI systems in Python or in JavaScript or in Java are this huge rigmarole of basically how screen drawing works, how you organize all these elements. There's this big structural lift that you have to figure out that is entirely handled through Morphic in Snap. And so to go through and recreate the visible tkinter parameters is really useful as a kind of lens for kids to see how those things are related to one another. But I don't think you would ever want to build, there's no benefit for you to build a tkinter interface in Snap, in Morphic, to output it into.
Correct. Yeah. There is not a lot of benefit in this, but it gives you an idea. You stay in your environment. You stay in your environment. You stay in your Snap environment, and you can start to understand what does it use. What is a widget? How 100%. Does it work?
Like I would think that this would be a great way to do the first one button, one field, one pull down interface for tkinter for people who are familiar with Snap. But the first time they want to do something a little bit more complicated than that, then it's like maybe you can use this as a prototyping platform when you're trying to figure out your ideas, or if you have something that you've written in tkinter in text that isn't resolving well, come back and try to build it together in Snap to see if it helps you.
Yeah, maybe that's one step to. I was thinking about this graphical user interface more in the terms of teaching. No?
Yeah.
More in the terms of teaching to understand how does a graphical user interface work. Because if you're coming from Snap, all you know are sprites. And understanding how this works, and I mean also behind it that you have an event loop and everything. There's so many things you can learn in Snap, and where this is the next step, no?
Yeah, absolutely.
Okay, I think that was it. Okay, yeah, then.
Thank you.
Thank you. I'm sorry. I mean, I wanted to present something where everything works, what you see on the screen with all graphical user library, tkinter in Snap. All I showed you was how a button works and so on. But I think it's more important on how to, what the idea behind is, to have, what you can see here, to have blocks which behave like some Python blocks, some Python text. Okay, yeah, then it's my, then yeah, thank you, because the time is over. So.